Welcome to qnawire.
Our question says to look at figure 9-64, in which block A has a mass of 1.6 kilograms, m sub A, and block B has a mass of 2.4 kilograms, m sub B. And it's moving along a frictionless plane. The direction of the three velocities are going to be appropriated as I or F for initial or final indications. VA sub I, the initial velocity of block A, is 5.5 meters per second. VB sub I is 2.5 meters per second for the initial velocity of block B. The final velocity of block B is given to be 4.9 meters per second, and it wants us to find A, the speed, and B, the direction, left or right, of the velocity of block A for the final, and then the collision, whether or not it's elastic or inelastic. So to do part A, we'll indicate this as part A, we're going to use conservation of momentum, which the initial momentum is ma times the initial velocity of A plus m sub B times the initial velocity of B is equal to the final momentum of A plus the final momentum of B. We know everything here except for the final velocity of A, which is what we're asked to solve. So we can arrange this equation to solve for the final velocity of A. It's going to be ma VAI plus, well, it's going to be MB VBI minus MV times the final velocity of B. So the mass of B is common in both of those. So just to simplify this a little bit, this is going to be MB times VBI minus VBF. And then this is all divided by the mass of A. So plug everything into this expression. This comes out to be 1.9 meters per second. Okay. And then for part B, we're asked, is it moving to the left or right? But since it's positive, it has to be moving to the right. So we can write here okay. And then for part C, we're asked if it's an elastic or inelastic collision. So to do that, let's compare the initial and the final energies. So 1/2 ma times the initial velocity of A squared plus 1/2 mb times the initial velocity of B squared. So plug those values into this expression, and this comes out to be 31.7 joules. Okay, now let's do the same thing for the final kinetic energy. 1/2 mb VBF squared plus 1/2 ma VAF squared. Okay, plug those values into the expression, and it's also equal to 31.7 joules. So since K initial equals K final, this is an elastic. Okay, we can box that in as our solution for C.